Kia ora, here's the last of what I'm assuming is the set of excellence questions for the complex numbers paper. This is question 1E. And again, I think this is a pretty straightforward question as long as you work carefully through it. We've got two complex numbers and we have to form a third, which is called W. W is U over V. And we have to show that it won't lie on the line y equals x for any value of k. K is a real constant. Okay, so what we can say here is, here's our little sketch. The line y equals x looks like this. All right, and so what we've got to show is that the imaginary and the real components are the same, and if they're the same, then it will lie on y equals x on that line there. That is the most appalling line. If you drew that line in an NCEA exam, I'm sure you would get no marks. So let's just draw another nice line with a little ruler. There, right, so this is what we're trying to do. Keep that in mind for the whole of the question. And then the steps, I think, are fairly obvious. We first have to set up what u over v is. So that's 2 plus 3ki over 4 plus 5ki. We multiply by the conjugate of the denominator over the conjugate of the denominator, and we clean it all up. So starting in the denominator, we get 16 plus 25 k squared, right, so that's that. These go away, that's the whole point of the conjugate stuff. So we've got 16 plus 25k squared. Doing the numerator, we get 8 plus 12ki minus 10ki plus 15k squared. That would be a really good time to stop and check that you haven't mucked it up before we go any further. So that gives me w, which is u over v, is equal to 8 plus 15k squared over 16 plus 25k squared plus 2ki over 16 plus 25k squared. So if y equals x, then we need to have the real part of w is equal to the imaginary part of w, which means that we're solving this, and our goal is to show that there are no solutions. So if we write out those two parts, the real part and the imaginary part, then as we often find in complex numbers problems, we don't care about the denominator. So we can just multiply through both sides by this. That leaves me solving this. So that's a quadratic. 15k squared minus 2k plus 8 is equal to 0. Now we could just solve it, or we could just show that there are no solutions by using the discriminant. So that's what I did. So the discriminant is b squared minus 4ac, which is 4 minus 4 times 15 times 8, 4 times a times c, which gives me a massive discriminant of negative 476, which is negative. Therefore, no real roots exist. Or you could solve it, and I know you guys probably bunged it into your graphics calculator and showed that you got k is equal to 2 complex numbers. In fact, I might just do that now just so that if you're watching this and you want to check if you got it right, we'll do that. So solving it with the quadratic formula gives me k equals negative b, so 2 plus or minus the square root of, gross, okay, negative 476. Yeah, I don't know why I said I'd do this, divided by 30. Okay, you can go from there. I haven't got a calculator on me. I'm sitting downstairs at my kitchen table and I can't be bothered going to get it. But you could solve it, and obviously you're going to be getting 2 complex roots, not real ones, and I know there'll be conjugates of each other, so there are no real roots. So that means that there's no real value of k for which the real part equals the imaginary part. Therefore, w never lies on the line y equals x. All right, I think that's a pretty nice, I think it's a pretty easy excellence question compared to some of the years. So hopefully lots of you got that right, and I think overall this exam was a really, well, the excellence parts, actually that's all I've looked at so far, were really pretty fair, nothing too unpredictable. I'm going to try and do integration next, but that will probably be tomorrow night. Thanks for watching.